Welcome to a new video on my channel, and this is going to be another Grafana InfluxDB content. And I'm doing this because I'm building some new dashboard in order to look at my electricity usage versus solar generation. And also this is a good time for me to refresh my Flux knowledge and Grafana knowledge, because I don't think I've made any changes to any of my dashboards in the last year, and I'm certainly forgetting some of the Flux nuances. So it's it's just a good refresher. But then the main reason I'm doing all this because I have solar panels installed on the roof, and for the past 10 years I was in a special tariff which allowed me to basically accumulate the solar generation that the excess generation that I generated over the summer, and then use it in the winter. So I only had one bill per year, and for that bill the electricity company just basically calculated all the usage for that year versus the generation, and then subtracted the two together. So for the past time I was able to just use all the electricity that I generated in the summer, and I was able to use it in the winter without any extra cost. I mean, obviously this was a very very good tariff, and that was sort of the incentive for initially to install the solar panels. I mean, that happened back 10 years ago when there were no government subsidies for this, so that was the incentive. But then the 10 years have expired, so I'm back to the normal tariff where I am billed for every single kilowatt hours that I used, and I get money back for every single kilowatt hours that I feed back to the grid. Of course, the feedback tariff is fractional of what I buy the electricity from. So it would make sense to think about how I can even out that difference. I mean, obviously there would be some sort of battery pack, but to be honest, I'm just not really sure how to go about this. Obviously, I don't want to jump into any solution at the beginning. I want to look at data, because I have data to somehow size this and also estimate the return on the investment, and actually just make an informed decision whether this is a good thing to do, whether it's financially sort of like responsible. And of course, if I would get to the point where, let's say that a certain size battery is going to be it will make sense for my setup, then I can also look at if there is any government incentive to buy something like that, because there's always some stuff for solar panels with battery storage, and these stuff are coming out of the EU all the time. So there could be something which would make the the equations, the financial equations, more favorable to invest in a system, but we are not there yet. So what I have done now, let me just change the view, is previously, a long time ago, I think you have probably seen this graph, which let me just change the view. So this shows me everything that I get out of the 3 different inverters that I have on the roof. So I mean, today is not a bad day, but it's going overcast now. It was sunny in the morning, so there is some generation, and these are the stats for the individual inverters. I mean, you can go back to a previous video where I explain why I have 3 different inverters. It's a long story, and that's the output of the 3 inverters added together. And this is how my basically grid usage looks like. So anything above this 0 line here, so everything in the red area, is where I use power from the grid, and this is where I actually have more solar generation that I use in the house. So there is more stuff which goes back to the grid. And if I go back to, let's say, 2 days, maybe I can zoom into this area. So this was a more sunny day, so you can see that in general I'm in the green, and of course something turns on, and that's midday, so probably we're cooking or something like that. So this is January, so there's no way I would be able to cover a 4 kilowatt consumption during January. I mean, probably it's possible in the summer, but I wouldn't bet on that, especially because the load is so unequal. You can see that I'm pulling all this power on a single phase. So that's why I'm saying that this is most probably the hob, because I think the oven is a 3 phase, but the different hobs are single phase. or probably it could be a combination of the hob and the microwave or the kettle. But yeah, they usually spread across the three phases. But yeah, you can see that, like for example, at this point, pretty much I was feeding back 700 watts to the grid, 1000 watts on the I mean, sorry, this is consumption, this is not power. But then on the other phase, it was almost the same as the other two phases combined, electricity use from the grid. So I have all these data, and I figured out I can build some more more queries that will allow me to get all this information and look at sort of 24-hour periods. But instead of looking at 24-hour periods, I want to look at periods from morning to morning. So when the solar inverters kick in until the solar inverters kick in the next day. And I was thinking about looking at three different distinct data. So one is how much energy I have returned to the grid yesterday. So this is everything that I generated on top of what I was consuming in the house. And this is not a great figure, but I think yesterday was a very overcast day as well. You can see this is watt hours. And then I can look at how much electricity I used since sunset yesterday all the way to the sunrise this morning. And this query has some issues, so this is why it is not showing any data. And then what is the daytime grid consumption? So again, from sunrise to sunset, and how much I was getting from the grid on top of the on top of the solar. So anything that the solar wouldn't be able to cover. And technically, if I can store this figure, because that's the excess generation yesterday. Let me turn on my phone, the notifications. So if I can do that, and if I can store this one, I can feed it into the either to the daytime grid consumption or to the overnight grid consumption. And of course, you can see from the numbers, there's no way it is possible to cover these two. But this is probably the worst case scenario because it's January. We have some very overcast days. In some days, the solar generation is pretty much negligible. And what you see here is that this calculation runs every single day. It runs in the evening, and I found that when it runs in the evening, I don't have issues with this figure here, so that it always gets calculated correctly. I still couldn't figure out why it happens. It's something probably in a flux, but when we look at the flux query, I'm going to go into that in a more detail. And so every night this calculation runs, and then it gets stored in influx again as separate values. So it is more easy for me to create a charts like this. And I've created two of these bar charts, and they display exactly the same data, but I just used, this one is a time series chart, and this is a bar chart. And I'm not entirely happy with either of these because I wanted to combine lines and bars, and the way the standard graphs in Grafana handle it, I'm not really happy with them, but that's what I have at the moment. That's what I can work with. And what you see here is the red bars are the daytime grid usage. So again, the excess grid usage on top of the solar generation. The orange ones are the overnight usage, and then anything in the green, that's the daytime generation, so excess solar generation, which goes back to the grid. And the purple is just the difference or the sum of basically, adding up the two consumptions and then minus the generation. And obviously you can see that all of these values are positive at the moment because in the winter, there is no way I can cover my generation with no way I can cover my electricity consumption with solar generation. And in particular days when it was overcast, it gets really bad, like 7 watt hours for the entire day as excess solar generation. So pretty much everything that the solar panels or the inverter was managed to squeeze out from battery was immediately used inside the house. And I have some here on the last 2 days. And so in theory, if I'm thinking about, let's say, battery storage, I should be able to put this much electricity into a battery and then use it to offset either the red or the orange bar in the next 24 hours. So I think that this is the information that I would be able to use to give a very specific battery sizing forecast for myself, which is completely tailored to my consumption and the way we live and the way we live use the electricity in the house. So in the rest of the video, I just want to go through the technicality of these graphs. So going to show you all the influx queries and what I have done. And I mean, if it's too technical for you, you can probably just skip the rest of the video, because there is nothing I can tell about this at the moment, because the idea is that I will keep running this process for the, let's say, at least for the next 6 months. So I see a half-year cycle from the from the winter to spring all the way to the height of the summer, and with that probably I can extrapolate the data for the rest of the year, and I can see a full cycle and how these values change over this period, because I can definitely tell you that these numbers are going to look vastly different in the summer, and of course they are looking they are going to look much better, but they are looking pretty bleak at the moment. But I need to look at this this whole spectrum in order to provide an informed decision on what I can do or what makes sense financially. Okay, let's go into the technicality. Let me just deal with the easiest one first, which is the results that I get here. So in the influx, I have a Node-RED bucket that I use for pretty much everything, and I use this sensor measurement, which I pretty much use for everything. So basically in the sensors, I have a device key tag. I always forget how this called. So there is a device tag, and I created a new device tag, which is called the solar stat. And it has 3 fields: the daytime grid, overnight grid, and the yesterday return. So these are the 3 boxes in the chart. So the 3, the red, orange, and the green. And the purple gets calculated dynamically. So we are going to see that. And if I show you these for the last 30 days, you see the data. So because I calculated and stored it in a database, displaying it becomes a lot more easier. So if we look at the query behind this, behind any of the chart, then I can scroll. Let me just rearrange the screen. So you can see that I just select data from the bucket. I use the range, which is the time start and the time stop. So whatever is selected up here. And I filter on measurement sensors, the device solar stat, and I look at these fields. I mean, that's the only field that I have at the moment, but okay, let's look at these fields. And when I execute this query, then if we look at the table, then, if I execute these query, so let me just comment out the last 3 lines. Then I got a table stream, which obviously has 3 different tables because the 3 different fields, and then I get all the data, and this data gets generated once a day. So basically, I have statistics for every single day. So what I wanted to do is, well, first of all, I wanted to create the balance, and for this, first of all, I had to do a pivot. So I do a pivot on this, and the row key is the time, because the time is the same for all of these 3 fields, because they are saved in the database at the same time, or ingested into the database at the same time. And the column key is the field, so it's either daytime grid or the overnight grid or yesterday returned, and the value is obviously underscore value. So with this, the influx transforms the table stream into a single table, where each of the different values go into columns with the with the field names. And we still have the start and the stop and the measurement and the device. So next I thought I'm just going to remove everything that I don't need for the data. So I remove the stop, start, device, and measurement. So I get a nice table like it would be in Excel or something. And because I have all the free values that I want to use for the want to calculate the balance from in a single row, I can just use a map function. So I create a map function where R is record and R with balance. So the balance is the new field value, and that's the daytime plus daytime grid plus overnight grid minus the yesterday return. So that calculates my new field here, which is called the balance. So this is the information that I pass over to the to Grafana. As you can see, that's the flux query. And yeah, so I have created two different versions of the exact same flux query. The first, I used a time series because time series is the only option where you can combine bar charts and line charts. The only caveat is that you cannot create what you can usually do in, let's say, Excel, is that you can have like let's say, multiple bars next to each other and then the line on the top. You can't really do it here. So it either puts the bars on top of each other, like it puts them next to each other with an overlap, which is absolutely stupid. I don't know why anyone would do that. Or you stack them up. But I think in my case, I mean, maybe stacking would be good, but I think it's visually much easier to interpret it this way, that they are next to each other. And I wanted to have the balance in a line because it's a different set of data, and I wanted to visually separate it from the rest of the bars because that's just the created by equation. It's not the raw data that we have to work with. But the way I managed to create this visual at the end is obviously with overrides. So you create the time series, and the special things that I configured here is I selected the default style as lines, because if you do bars, then everything becomes bars and you cannot convert some of them back to lines. So I said, okay, I want to use lines, and this interpolation was the line width, and the fill opacity is 0, because otherwise you get a shadow under the line. So that's 0. And the line sign is solid, and then the unit is watt hours. So it automatically converts to kilowatt hours when it's over 1000. And I want to use classic palette because I'm going to redefine the colors later on, and I removed all the thresholds because I didn't want to use them. So then I started to create overrides. And well, obviously I usually create overrides for every single value that I want to display, mostly because I want to replace the technical names with the nice human readable names. So the first one is the daytime grid. So it has a different text, and then it has a color scheme, which is a single color. So that's the orange. And here in the override, you can specify an override which says bar style, graph style, and here you can change it to lines. So that's how you can control that an individual series is displayed as a bar instead of a line. So again, you can see that you can have multiple lines or multiple bars, and I think it would look great if you have a lot of lines and one bars, but I wanted multiple bars and a single line, and you can do points as well, which I guess it makes sense in a few cases, but I wanted bars. So visually I can, tell the different data series apart, like, what is like calculated and what comes from the statistics. I mean, that's calculated as well, but anyway. And for each of these bars, I also specify the fill opacity. So that's the fill level, and I couldn't set it to 100% because then the bars are going to just completely overlap each other and hide the other bars, but that's what I could do. And so the only way I was able to just move these bars relative to each other is to use this bar alignment. And I happen to have 3 different bar alignments. So one of the bars is aligned to the left. You know, the data series, the time is in the middle, so the bar is aligned to the left, the middle, and to the right. So that's all I could do. And funnily, I also wanted to see if I can reduce the bar width, but in the time series graph, you can't do that. On the bars you can, but not on the time series, because it would be nice if I can make them skinnier, because then they can just be next to each other, but now they're always overlapping. So I mean, clearly they haven't designed this time series graph for this specific application, but that's the best I could do. So that's the first one. And then the second one, again, has a different name, has a different color. So that's the orange. That's bar style as well, 50%. That's aligned to the middle. And then the last one is green, a bar aligned to the right. So these are the green stuff here, the green bars here. And finally, I have the balance, which is, you know, I don't have a separate style for that. So that picks up the default line style. And again, I just picked a single color and I defined the name as balance. So that's how this visual was created. And I think it looks good. As I said, if I could make these bars narrower, then it would look even better. And it would look exactly the way I want it. But unfortunately, it doesn't work like that. And the next is I have the edit. Sorry, on the on the next panel I have a different style. So it uses exactly the same query, but the type is bar chart. So as I said, I can do as many groups as I want, but I can only make them bars only. So yeah, no rotation, nothing. So this is where you can you know, specify the width of each of the groups, and then you can also specify the width of each of the bars. So I think it is highly customizable. It makes, you can really, you know, fine tune the visuals, so it is easy to see and easy to interpret. Yeah, that's it. And yeah, I can have the line width and the opacity as well. Probably the only other thing that I'm missing is that on the time series, I was able to customize the x-axis, so it only shows me the days, because I don't really care about the time. It's always going to be, well, I was doing some testing here, but I mean, from now on, all the data will be calculated at 9 p.m. So it would make sense for me not to show the time here, but yeah, anyway. So there is no option here to format the X series, or at least I didn't find it. But I still had to use the override. So again, I removed the thresholds, and in the overrides, I created an override for every single field. Mostly, again, just to change the display name and give it a different color. And I used the same colors as the graph up. And there was no other, you know, override property that I could use to differentiate these bars from each other. So here I think, I mean, this particular graph, I think it would make more sense if I would just remove the balance and then look at these 3 values together. And the other interesting thing about these 2 graphs, if I pick, let me just pick 30 days, is that the time series obviously shows the entire duration, what is selected up here. So you can see that I had some data here, and then my calculation had some issues. Actually, I was away for the weekend and something didn't run, and I couldn't fix it. So I have a gap in the data here, which, I mean, it shows up in this time series graph, which makes sense, because if you want to look at the time series, then it's probably, you know, more useful to see gaps in your data. But then the bar chart just hides anything which doesn't have data. So you can see that from 20th of December, the next one is 1st of January. So 29th and 30th is missing from here, and 31st is missing here, whereas you can see the gap here. It's fine. I mean, you know, normally this data should be generated once a day, which means that, you know, going forward, I would have data for every single day. So both of these charts are going to line up, and, well, they should line up, and they will. as long as the calculation is running and everything is going without any issues. And going back to the calculation, I think I could have done this with jobs in resizing. So I could have done this with jobs in InfluxDB as well, but I decided to do it in Node-RED because I think I just have a little bit more control how it works in Node-RED. I can do a little bit more debugging, but again, you can do this with jobs because all I'm doing here is this job runs every single day at 9 p.m. and then it runs the 3 different queries that you can see here. So the yesterday's return, the overnight consumption, and the daytime grid, and then it calculates all these different values, and then it creates a it inserts it into Flux. So you can see that it inserts into measurement sensors, and the device name is SolarStat, and then it creates 3 fields with the 3 values which comes out of the 3 different queries. And it also shows me the last one. And previously I had issues. What you can also see here on this overnight consumption, that it gives me an error that the range is empty, even though I'm pretty sure that the range is not empty. So I had these restart functionality here, which if it fails, then it tries to run the query for the second and the third time, and it usually runs for the second and the third time. So again, I can't really explain why it is happening. I created a new post on the Influx community forum, but I haven't received any useful information yet. So I yet to find out, but maybe it's also has to do something with the timing. But if I show you the Flux, it doesn't make sense that timing should play a part in how the Flux query is executed. So finally, the results are ingested back into the Flux database, and I also get a Telegram message, so I can see that it's all running. So I get these at 9 p.m. every single day. So that's all the the data generation. But now let's look at the actual queries behind these 3 different panels. So these 3 panels just run a query, and the query returns one single line with the underscore value which is displayed here. And it's a very complicated query, but I managed to reuse pretty much everything what I've learned from building previous queries in the past. So let me just copy this into a notepad because I think it's going to be easier to see. Okay, so this is how the query looks like, and in fact this is not as complicated as I thought. Well, the first one is not as complicated as I thought. So first of all, I import a library which is called experimental, and that is required for these things that you can see here. So what I'm doing here is I'm looking at my sensors that are measuring the 3 phases that come into my house, and that has a Shelly 3 EM connected to it. So it's looking at all 3 phases, and this Shelly is measuring the energy imported from the grid, which is called the total, and the energy exported to the grid, which is the total underscore return. And this is like ever increasing counter, so I can just look at what was in the morning and what was in the evening, and if I subtract the 2 together, then I can tell how much I was getting from the grid or feeding back to the grid in any given period. So I look at my sensors. If I go back to the query builder, so it's Node-RED, sensors, and the device. So the device is called this house phase 0, phase 1, and phase 2, and all 3 of them has this total and total returned. And actually, I think I made an assumption here in this query saying that I don't have any other sensor or don't have any other device which has the same field, because otherwise that one would be selected. So maybe it would be a little bit safer if I list if I filter on these 3 devices as well. Otherwise this is just going to read some additional garbage, well, not garbage, but additional data which I don't need. But regardless, this is how it works at the moment. So I filter on these the measurement sensors, and filter on these fields, And if I do this, if I put this into the script editor, then, oops, and I do that, you will see that it returns, oops, import experimental. Then it returns the data for the last day. Submit. Yeah, probably I can display this. Oh, okay, these are such a high numbers, then obviously you don't see the difference, because these are calculating the energy returned or the energy used since for, I don't know, 2 years. And so this has such a high value that you don't see the single day's difference in a chart. But you see, I have the data for the entire day. And as you can see here in the range, I have used the start as, well, the stop is today. Today always gives me the current day 0 hours 0 minutes. And the start is experimental sub duration, so subtract duration. And from the today, I extract 24 hours. So that goes to the midnight of the previous day. So that's basically, this range is going to cover the entirety of yesterday. And from this, I select the first data. So that's basically what the meter reading was at the beginning of yesterday midnight. And also I run almost the exact same query, but I select the last one. So the first is going to give me the first measurement, or the first, let's say, meter reading for the day, and the last meter reading for the day. And again, I drop some of the columns that I don't need, and I join these two tables together, and which is going to give me all the data that I need. So if I do this, and if let me just comment out these two lines and submit, and I put it into a table, because we are only dealing with a few amounts of data. So I have the first value and the last value for each of the different phases. So you can see that was the meter reading in the beginning of the day, that was the end of the day, and then for the 3 phases. So now I can again run a map which just calculates the last minus the first. So that's the consumption for the day. Sorry, this is returned. Yeah, total return. Interesting that it's absolutely 0 for one of the inverters, like that inverter never run. But probably that was the way it is. And then I can sum all the values together, and you can see that that was the full returned electricity for the day. Okay, the reason it was 0, because probably the entire generation of that inverter was used inside the house, so nothing actually went back to the grid. So that's the 34.7, which you can see here. So that was simple. The next two is not going to be that simple. So I copy and then put it into a notepad, and you can see that it becomes significantly bigger, because I have to do a lot of different selection before. So first of all, I need this experimental again, because I need to calculate, I need to run this duration, subtracting and adding dates. And what I have in most of the query here is basically calculating this graph here. So this graph takes the output from the 3 different inverters and adds them together, and that's what I'm also doing here in the beginning of the query. So I get the first inverter, which is the garage inverter, then the second inverter, which is called the small, and the third inverter, which is called the old, and I add and I create a union from all these data. So as you can see, everything is all the queries are running for the previous day. So I take the data for the last 24 hours, for the entirety of the last day, and I add the 3 inverters together, and whenever the value is 0, I just insert 0, and at the end, at this point before this last, I get the same graph back that you can see here. So I can see how the generation was going, and from this I can look at the last data, and that's going to tell me what was the point where the inverter stopped working because it was just too dark. So this is what I use in the for this last. And I do the whole thing again. Again, looking at yesterday, no, sorry, this time it is looking at the current day, and I do the whole calculation again, and I look for the first one. So basically I found the time when the solar panels stopped producing electricity yesterday and when they start producing electricity today. And then I union these two tables together, and I use this find column just to look at the time, because I'm only interested in the time. So the timestamp of these two readings. And now I'm doing the same sort of selection that I was doing before. So I look at the sensors and I look at the three different phases. You can see I did the filtering here. I included the filtering for the same phases, and I look at the total. So that basically is going to give me all the meter readings for that period since the solar panels stopped producing and all the way until they started producing electricity again the next day. So all these readings go into this power data variable, and I do a table join again. And I learned this trick from one of the comments in the community forum, that you can create a table, and then when you create a new table with this join, so join tables, then obviously you give what is the start and the end condition. Sorry, what is the sorry, not the start and the end condition, but you give two different tables that you want to join together, and then you use this the start and the end, so it uses that as a prefix for the new fields. And here, normally I reference to a variable that I pre-selected from the previous selection. But then you can also use additional flex commands in here. So in the previous one, I was running a query twice to select the first data and the last data. But what I'm doing here is I'm just running the query once to select all the data, and when I'm constructing the second table, I use the first variable which contains all the data, and I use pipe first, and then the end is the same but pipe last. So I only need to run the query first, and I pick the first value and the last value, and join those two single records into a new table. And I use the joining field as the device because it's going to be the same on both of them. And let me see if I can show you, if I can generate this for you. So I'm just going to comment these last lines out. And if I submit, yeah, that's the problem. I'm getting this information, cannot query an empty range. And if I play around with this value, sometimes I get the answer that I need, but I don't understand why this is not working, because I definitely have data for the last 24 hours. And as you can see, none of my ranges actually depend on what I have selected here. So if I go back, comment out this one, I remove the power data, and if I do this, then if I comment out this one as well, and the issue is with this statement. So if I comment this out, and if I comment this out, so you can see in the union I have the two pieces of information that I need. So this was the time. These timestamps look a little bit odd, but I don't know why they are that day, but they are actually the right pieces of data. So this is when the solar generation started with 7.2 watts, and this is when it's ended the next day with 12.0207 watts. So I have the two, to do data, the first and the last one. So and I need to use this find column function, so I can reference to these two values using, as an array. And I have the two pieces of information here. So, and if I use the exact same queries at different times of the day, one time it works and the other time it doesn't. But I'm always looking the data the previous day. So I don't really understand why this doesn't work. And if I'm going to show you on the next query, it works. So I'm using the exact same methods and same statements. I mean, not the same, but same concept, and it always works. So there's something funny going on in Flux, or maybe it's not nothing funny, but I just don't understand this. I would be love to get an answer on this one, and if I do, I will let you know. So as you can see here in the timestamps, I have the times for the yesterday's solar and the today's solar. So that's when the solars stop producing yesterday and when they start producing today. And based on those two timestamps, I can look at all my meter readings, and again take the first and the last for that period, and then I just start calculating all the different the difference between. So you can see it's the same as before. So I calculate the value and underscore the value start. So from the power data, I get all the meter readings under value. And then when I join them together in a table, and because I have specified here start and end, my new fields would be underscore value underscore start and underscore value underscore end, because of these, start and end. And once I calculate the difference, I can drop any of the columns that I don't need, and I can also do a pivot, and I do a final mapping, because all of this information is calculated 3 times, because I have 3 phases. So at the end, I just add all the phases together, or the consumption, all 3 phases, and that's how I get a single figure at the end. Maybe I could have used sum here. Well, not after the pivot. Maybe instead of the pivot, I could have just used sum, but it gets me the same end result, so yeah, that's fine. So that's how I get the overnight grid consumption. And then finally, I calculate the daytime consumption, and that is going to be very similar query to the previous one. I just play around with the dates. So here I'm using the solar data, again, just to calculate the beginning of the period at the end and the end of the period. So you can see I'm doing the same stuff. I'm querying the 3 different inverters. I am adding them together. The only difference is that I use a different, periods up here. And yeah. So again, I just have to use, because I'm looking at the older generation today. So this is calculating the daytime grid consumption. So I'm looking at today. So you can see that actually I was looking at yesterday, because I'm always looking back the previous day. But this is a period from 0 hour yesterday to 0 hour today. And then I just do it for all 3 inverters. I add them together, and again I use this timestamp and the pipe function here to get the first data and the last data. So again, that will give me 2 timestamps, and then I can run a second selection using the timestamp 0 and the timestamp 1. So basically these 2 timestamps will be like an array with 2 elements. So the first element is the start and the second element is the end. So this is what I can use in the range. And I look at the my Shelly 3EM again, but the last time I was looking at, initially I was looking at the total return, but now I'm looking at the grid consumption. So I'm looking at the total meter readings. And I do exactly the same calculation as before. So I calculate the difference between the last and the first one. I remove some of the fields that I don't need, and I pivot. So I have the 3 different phases in columns, and I just add them together. It's phase 1 plus phase 0 plus phase 1 plus phase 2. Again, here, maybe instead of the pivot and the map, I could have just used the sum, because I need the end figure at the end. And if I show you this in the Flux query, Uh, oops. Let me just quickly comment out all these lines and comment out this one as well. So here again, I get the 2 timestamps. So today is the 6th, so that's yesterday. So yesterday the solar started at 7:50 and they ended at actually in the afternoon 16 or 4:35 in the afternoon. So if I do a find column on this, then we are not going to get a result because then it's not able to display this. But anyway, that's not a problem for me. But now what I can do is I can put this into this bucket. So you see, I'm getting these identifiers again. Oh, of course, because I commented out, so I can run this. So that was my bad. So now I have the meter readings for the entire day. You can see that the start is from 7:50 in the morning until 4:35 in the afternoon. So I have all the readings for the entire day, you know, hundreds of readings for all the different phases. And now I can join these together. So instead of running this query twice and adding the first and the last here at the end of this and then doing everything twice, now I can just use it here. So the power data pipe first and power data pipe last. So that basically just selects the first and the last entry from what you can see here. So I will end up like that. So you can see that it has duplicated all the different, you know, start, stop, measurement, fields, everything. But what I need is value end and the value start and the corresponding values. And I have, so this is still a table stream because the original was a table stream with the 3 different fields. And again, I have a table stream for the 3 different fields. So I can, what I have done after that is the join. I created the difference, which is the underscore value. So that's the difference between the first and the last meter reading for the different phases. And then I dropped all the fields that I don't need. So it looks much better. So the 3 readings. And as I said, I could have summed this, but I decided to pivot. So that basically just flips the, it combines the table streams together. So now I end up with a much simpler table with the 3 values together and for the 3 different phases. I even, you know, dropped all the time information here because I don't need. And I created another mapping which then calculates the sum of the 3. So that's 3,111 and that's get converted to 3.11 kilowatt hours because this is watt hours. So yeah, and I mean, I think I store this information once every minute, you know, all the 3 phases. I mean, it's that's 3,600 readings per day. And I'm selecting it multiple times, but still, as you can see, it only takes a split second for InfluxDB to do all these different calculations and then spit out the final value. So it is pretty fast, but obviously when I'm looking at like a 6 month period, I didn't want to go through all this calculation. This is why I am doing all the single calculation once a day, storing it again in a database. I mean, it's like, you know, downsampling this huge data set to like essentially 3 different values for a single day. So then, you know, the subsequent reporting is probably going to run much quicker because then it just, you know, straight selection on a very small data set. Cool. So that's where I am at the moment. And I mean, the data is already very interesting. I won't be able to, you know, draw any conclusions from this. As I said, it's the beginning of the year. The way the weather is and how much I generate and how much I use electricity is going to be completely different from 1 month now and also like 6 months now when we are in the summer. I mean, I definitely use electricity. We run the lights more because we have much longer dark hours, and you know, do a lot of stuff in the evening. And at the same time, this is where I have the least amount of solar generation. But I think it all, you know, it's all, you know, common sense in northern countries, or yeah, I would say probably like northern countries where we have, you know, like significant cycles of summer and winter. But that's why I'm running this exercise, to have all this data. So hopefully at the end I would be able to make an informed decision. Okay, cool. I think that's going to be all for today. I believe all this is very specific to my setup and the way I collect the data, and you know, from the solar panels and also from the various sensors. So I don't think that publishing these set of queries is going to be useful for anyone. I think probably it was just more useful to explain how it works and how I get all this data, all this accumulated and calculated data from the raw measurement data, well, the raw measurement data that I have. And I hope that was useful for you as well. So I think that will be all for today. Thanks for watching, and hopefully see you in the next one.